This video explores the art of vanishing, an attacker's playbook on successfully compromising a system while concealing their presence in tracks. A successful cyber attack is a sequence of actions, not a single step. The attacker's path involves 3 phases: breach, ascent, and vanishing. The final goal is to maintain access while remaining invisible. Phase 1. Breach. This is the first step into the shadows, focusing on obtaining initial access to the system. Keys to the kingdom involve breaking Windows passwords and authentication mechanisms. Windows stores passwords as LM and NTLM hashes in the SAM database, which can be extracted for offline cracking. Password attack types include non-electronic, active, passive, and offline attacks. The attacker's toolkit for hash extraction and cracking includes tools like "PWW7, for SAM hash extraction, and "John the Ripper, for brute force cracking. Other tools like Responder and Mimikatz target protocol attacks and pass the hash exploitation. Kerberos compromise involves attacks on the heart of Active Directory. AS-Rep roasting targets user accounts with pre-authentication disabled, allowing the attacker to request a ticket-granting ticket and crack it offline. Kerberoasting allows any domain user to request a ticket-granting service for service accounts, enabling offline password hash cracking. Phase 2. Ascent. This phase is about moving from a guest to the system master through privilege escalation. Escalation can occur through system vulnerabilities like DLL hijacking, where a malicious DLL is placed in a program's directory. Another method is through misconfigured services, such as unquoted service paths, which allows the system to mistakenly execute a malicious executable with system privileges. The royal move: escalation to system via named pipe impersonation. A low-privileged process creates a named pipe and waits for a high-privileged service, like system, to connect. This allows the attacker to impersonate the service's access token and gain system privileges. Phase 3. Vanishing. The final step is to erase all traces and become a ghost in the system. Digital trail cleanup involves deleting logs and history. This includes clearing Windows event logs using "webtoodle", modifying Linux logs, cleaning shell history, and manipulating timestamps of compromised files to avoid suspicion. Steganography is the art of hiding information within other, non-secret files. Attackers can embed malicious code, passwords, or exfiltrated data into ordinary image, audio, or video files, making them appear inconspicuous. Rootkit implementation allows the attacker to become part of the system by modifying the kernel or operating system files to conceal their presence. Rootkits hide files, processes, and network connections from administrators, filtering what the system sees. The attacker's path is complete. Initial access is gained. Privileges are escalated to system level. Activity traces are removed, and a rootkit is installed for prolonged, invisible access. The attacker has vanished. The defender's dilemma: how to guard the path. Effective defense requires a comprehensive approach covering every phase. Implement perimeter defense against breach, enforce the principle of least privilege against ascent, and use compromise prevention and monitoring against vanishing.